Hi, ladies and gentlemen. Christopher Ludwig here, Editor-in-Chief at Ultima Media, Automotive Manufacturing Solutions and Automotive Logistics. What a pleasure it is to welcome you all here to what is the last live stream hour that we're hosting this year across our AMS and logistics titles. And it's going to be a really interesting, exciting one, focusing on automation and automation in production and assembly, and particularly looking at how new technologies won't replace workers, but will help support workers in their roles to be more productive, more efficient, and indeed safer and more comfortable in many cases, whether that's use of cobots or indeed breakthrough technologies and innovations in artificial intelligence, which, as we'll hear, are helping to automate parts of the assembly processes, production, and logistics that previously we didn't before. So welcome again, everyone. We've got attendees from around the world and a panel that's really going to reflect the depth of this topic in industry. So before we start, I want to thank our partner for the live stream hour, Symbio Robotics, a really exciting company that we're going to be hearing from directly later, with some interesting software-led robotics and getting much deeper in the area of AI and robotics too. So very glad to have Symbio as a partner for this show. Together with our panel, we're going to be unpacking some of the key issues that we certainly see in the automation space and robotics, artificial intelligence, and as I mentioned, it's using this technology to reduce errors and manual tasks, therefore increasing the value of what workers in areas like assembly and trim and logistics are doing, which, as mentioned earlier, previously have been much harder to automate or introduce technology, whether that's now using things like cobots, smart AGVs, and other kinds of robotics. We're gonna look a lot more into that, and indeed the potential that comes a little bit further on, whether that's in areas like picking and kitting as well. We'll look at computer vision in robotics and what some of the steps are being made there. And we're also going to have a look at digital twin solutions, data analytics, how this sort of software and planning solutions are also being used to optimize processes in production, and assembly, logistics, and indeed often throughout the supply chain. So there's a lot to get through, and just a quick overview of our panelists today. We're going to be hearing from all of them, and we'll have plenty of time for Q&A from Matthias Schindler from BMW, Paula Carsi from Ford, Kevin Konkos joining us from Symbio, and Michel Mauvin from Cosmotech. We'll introduce them all later, but throughout, please put through your questions, which we'll be taking towards the end. We'll have some time with each of our panelists. With some presentations from Matthias Schindler, BMW, from Paula at Ford, and we'll have some Q&A time as well with Kevin and Michelle, followed by a live panel discussion at the end. So again, really exciting program for you today. Before we go to our first panelist, I'd like to introduce my co-host, partner in crime for this session, Nick Hult. Nick Hult, who is the editor of Automotive Manufacturing Solutions. So Nick, glad that you could join us today and share some of the insights that you've had. And one of the things I wanted to just quickly pull up, as the slide which I have here is indicating, we're just about to kick off or publish tomorrow our winter edition, which has a lot of focus on automation. And I thought, why don't you just tell us a little bit about what we can expect in this digital edition, as it features some of the guests that we have today, and what's coming after that.
Yeah, thanks, Chris. I mean, the focus of the piece really is unlocking the potential of automation. As Chris pointed out, it's been a challenge in certain areas, certainly assembly. Over the years, there have obviously been sort of cost-benefit issues with it in the past, but obviously the technology is now moving on rapidly. It's becoming much more sophisticated, the robots and the software. One of the key areas that we came across when we were doing the feature together were sort of challenges of product variation. That's quite a big challenge for anyone wishing to automate, certainly assembly operations. And accessibility, so simplifying the programming process and enabling the shop floor to be able to access the the software and the automation systems in a way that means it's less specialized and can be more broadly applied. And we've got some interesting articles on both those areas within the magazine. A key part of it would appear to be AI. So the use of AI systems, AI technology in managing the data and processing it is becoming a great enabler for the automation system. So that should be out tomorrow, very shortly, and we will be posting that online and across social media as soon as it's ready.
But thanks, Nick. We're really excited about that issue tomorrow, and we'll talk a bit more about some of the issues throughout this session. So before we do, though, I mean, now I'm really excited to bring on our first speaker and guest, Matthias Schindler, who heads up AI innovation in BMW production systems. Matthias, really glad that you can be with us. Matthias has been working on some really exciting projects in the artificial intelligence space, also in data analytics, as it applies to production. And as we're going to share some slides. So Matthias, I'm just going to give you access to share. So thanks again for joining.
Thank you, Christopher. Thank you very much for the invitation. And yeah, please give me the presentation. Right. Yeah, looks good. Thank you. So thank you very much. Today's topic is democratization of AI. I want to give you a little bit of insights about the BMW production system and our core beliefs with regards to artificial intelligence in the next round about 10 minutes. So, of course, whenever we discuss production, we have to have a focus on our products. It is our belief to bring all the single drivetrains onto the same assembly build, as you can see here. So, for example, not Plant Munich, but all over the world, we believe in integrating all the drivetrains, which means conventional combustion engine, diesel or petrol, plug-in hybrid electric vehicles, as well as fully electrical vehicles onto the same assembly belt. For example, in Munich, that means you can see it in the upper right, the i4, which is still the concept image in there, will be launched shortly on the very same assembly as all the other derivatives which are already running and the ones which will come. One of our key challenges is complexity. On the one hand, we believe in bringing many derivatives onto the same belt, which in our case at the moment means 55 derivatives. All over the world, we are talking about 31 facilities in 15 countries where production is running, and individualization plays a very important role for all of our customers. So as given here, 7 out of 10 customers focus on individualization, so they individualize their car, which for the BMW 3 Series, the actual model, means you have more than 1 billion possible combinations for only that one derivative, and you can have an idea what this in general means for our BMW production system. To be a little bit more concrete, I brought an example which we call the type plate case. The type plate case should be the example over the entire presentation. I prepared some, but not all of the possible type plates from one of our German plants in Bavaria. It's plant Dingolfing, where we produce 3 series up to 7, 8 series and so on. So very many different derivatives on the same line. In that case, it means, for example, that can mean type plate is 745 LE, the type plate is 530, 530E, and so on. So on the one hand, the type plate gives you an idea about the series in general, about the engine which is installed, and also if it is a plug-in hybrid car, which is given with the E. So of course, whenever you order a BMW 7 Series, you expect the correct type plate to be assembled. So if there's a 530E given for a BMW 7 Series, that would not be okay for none of our customers. On the other hand, some people do not want to have a type plate there, so they can configure it in the way that there is no type plate, but this is not possible for hybrid cars, as hybrid cars have to be signed in a special way, so hybrid cars need to have the correct type plate. This was the reason why we had an employee for every shift in this very tech, and he was checking all the rears of the cars. He had a look at the rear of the car, he remembered what was the given type plate, and then he typed it into a computer to see if it is the correct one, so if that fits the target configuration. You can imagine quite a boring task, checking around about 550 cars per day, no real value added, and this was one of the reasons why we brought up our first example of artificial intelligence here in manufacturing. So whenever we want to deploy artificial intelligence, for example, for these kind of computer vision tasks, first of all, we have the training phase, which we will focus on today. So typically you have to record some images. We will see later how many, but typically around about 100 images per feature. You have to label them. Typically, we do object detection. So as you can see here, for example, in the right part of the image, we want to detect if there is the X-Drive logo given and the type plate given. So we have to assign what we call bounding boxes. Afterwards, with this, we call it labeled training data, you can create a model. So typically you adapt a deep neural network, and deep neural network in the end does the computer vision task. To check if the performance is ready for production, we deploy the model, we test it with new pictures which have not been seen in the training phase, and if the robustness is okay, we will bring it up running. Not diving too much into the productive phase, which is mainly the operations of this deep neural network, which we have trained in the beginning. I will give you some insight about the training phase, which is really relevant for this kind of task. So as I mentioned, we're in plant Dingolfing. We are focusing on the type plate, and this was one of our first large AI use cases with special focus on computer vision. And here I brought a real result of this. So on the one hand, let us focus on the type plate in the upper right corner. We see a part of the image, so the camera acquires the image of the entire rear of the car. We also see this poor resolution in this specific area, so there's not too many pixels in general. And we see one thing which is typically pretty tough for conventional computer vision, which is a reflection. So at the 3 number, you can see there's a reflection which typically makes it impossible for any conventional computer vision to have a correct detection. Nevertheless, we see the prediction given in the upper lower part. We see 320i, which is the result, as well as what we call the level of robustness, so 99.99%. And with this confidence, level of confidence given, we can detect, this is 320i, which is probably pretty tough for human beings as well. For me, I'm wearing glasses, but I would not be able to detect this is 320i, and I wouldn't be that kind of confident to say that it's 99.anything%. On the other hand, we see this is a very robust solution. So we did what we call hot testing. We inspected the entire production of 1 week car production, and there was not one single error, neither pseudo positives nor pseudo negatives. So how do we set up such an AI? We brought a very short video in here, which would explain how to do that. As I mentioned, first of all, you have to take some training pictures. So typically we collect 100 pictures per feature. Afterwards, we label them. So either we pull these rectangle bounding boxes, or we classify them in correct or wrong. And this is all we have to do manually. So afterwards, the neural networks optimizes itself. So there is where you can call it intelligence, which comes into play. And afterwards, you can deploy right exactly this neural network to detect the, in that case, type plates. So we offer this kind of service in a self-service logic for all of our production employees. So this is what we call no-code AI. So we have a BMW labeling tool, which you can use without programming any kind of algorithm. But this is not only available for all of our internal BMW production workers, but also for you. So everybody in the world can access this kind of BMW labeling tool Lite. So this is why we published it. We believe in the democratization of AI and scaling AI, and this is why we brought that open source. So if you're interested, please go to our GitHub website, have a look at the code, and you can use it as everybody else in the world could use it. Of course, we first of all developed it for our 50,000 employees, which are working direct in production at the shop floor. And it's a really easy to use tool. We believe in AI must be very easy to use, so no hurdle to use it in general. We want to be a democratized solution and not only accessible by data scientists. And this is why we developed and why we published this BMW labeling tool. So with the help of the BMW labeling tool, almost everybody is able to configure its own AI to solve its own problem, in that case, computer vision-based problem, with very low manual steps. On the one hand, you have to aggregate some data. On the other hand, you have to label it, and then you just press the button, create the neural network, and that's it. So summing it up, first of all, we have the training phase. You record images, you label them. This is the only 2 steps you do manually. Afterwards, the neural network optimizes itself. Of course, there are many very popular frameworks already given, and afterwards you can bring it live and use it during production. this is what we believe in at BMW. We believe technology needs to serve people. So on the one hand, we bring AI to the shop floor. So all of our employees at the shop floor are capable of setting up their own AI with the help of our new BMW tool. But we think a little bit further. We think we have to go beyond. And this is why we made the decision to publish all these algorithms so you can access the BMW labeling tool guide as everybody else can do. If you're interested, please feel free to download it. Yeah, this is really our belief. So we think technology needs to serve people. With that short introduction, I'm at the end of my presentation. Of course, if you have deeper questions, don't hesitate to ask. Otherwise, you can ask it at the end of the other presentations. Thank you very much for your audience.
Thanks, Mr. That's a really interesting presentation. And I think it just, you mentioned there the sort of number of type plates that you had just doing off. I think when you see numbers like that, you realize how complex the customization process in manufacturing has become. And I think we'll pick up with you hopefully a bit later on that, with this bit more depth into this particular project. So thanks very much for that, and we'll see you in the Q&A session at the end of the presentation.
Absolutely, you're welcome.
I'd like to just thank our partner for this live stream, Symbio, and we'll be speaking with Kevin Konkos from Symbio a little later on in the session. Our next presenter is Paula Cowsey from who's a technology specialist in emerging technologies, which I think is a fascinating job title, at the Valencia engine plant at Ford. So we're going to invite Paula to join us. Great, there you go. So Paula, fascinating job title, and I know you've been, I think one of the bits for me that's very interesting about your role is the fact that you're actually working at Valencia directly with the production operations there. So I'll leave you to tell us a bit more about that and some of the projects you've been working on, and we'll look forward to hearing from you. Thank you.
Yeah, sure. So thank you very much. I'm glad to be here joining the session. And as you said, I think that the difference from the point of view that I'm going to give you is how automation and innovation is work from a team inside the production plant. So I will share with you. Okay. Here we go. So as I said, I'm going to talk about the innovation in manufacturing production environment. So we work here in the production line with a very variety of processes. We work with manual processes. We work with automated collaborative processes where we join the best of the robots and automation, and we join the best of people. And then we work also with highly automated process with very complex technology that should be very robust in order to allow us to be efficient. And finally, we got these products with high tech and a lot of complexity on the systems that works for a smart world. So how we got from the beginning to the end in this complex environment, this is what I'm going to share with you. And I wanted to bring this let's say, point of view to the discussion. So we are a group that works on innovation and engineering inside a manufacturing production plant. And we work with the different emerging technologies that you have heard. For example, big data. We work with autonomous vehicles. We work with robotics and overall collaborative robots. We work on AI with machine learning and some neural networks. And artificial vision. These are some of our focus areas that are on our production lines. So the thing is that we work in a manufacturing production environment that is very demanding, it's very complex, but it should be standard and methodic in order to get the efficiency and continuous that we need in order to get this high volume and very perfect products. So if we join this environment with the necessities of the current world, where we need to be curious and innovative, as you know, the automotive is just running a very uncertain moment, and it's very important to be disruptive and challenging, and be very dynamic and fast, to be the smartest and very different company. So how we join this both concepts that seems to be quite opposite. This is what we call the innovation process in production. And we want to highlight the difference that we have when you work with research and innovation in a lab or in a research area, that is very, very, very important for the company. And we work with our groups, for example, the advanced manufacturing group, but how we work with this innovation inside the plant. So the process is almost the same. We work with the idea generation step, then project definition, the approvals, project execution with the different phases. But the different point is that we need to focus on the long-term maintenance of this products or technical solutions. We need a very robust solution that has to work with different operators the whole day, the whole week, and even years, and to be a very robust and efficient solution. So this is why I wanted to highlight that what makes this possible is the team. The team is the differentiation to make this possible and to succeed. And this is translated into mindset. You need people that should be working with innovation and should adapt from the first phase where we are working with highly complex technical solutions in the research part, where we go beyond the complexity of these problems, up to the final process where we need very standardized solution, very robust solution, and to think how to translate all the work that we do on the lab to the line, where a lot of variables and a lot of complexity is working together. And these are the same team that are working from one point to the other point. So we are facing some different challenges because we are seeing that we need to have a standard and mature production line, but we need to be disruptive. We need a controlled production environment, but we are adding some risk with the technology that we are using. We need a production environment that should be stable, but then we are running dynamic and a lot of changes into the line because we need to go at the same speed that the world is running. And in production, we are focused on urgency. We need to solve the problems really, really, really fast. But at the same time, we need to be focused on a vision and a plan in order to decide where to go and how to use this technology in order to be more competitive. So I just wanted to add some real production examples that I think that are the best example of this successful story in Valencia plant. So for example, this is an AI solution working on the line where we use neural networks, as my colleague has explained. What we do is to listen the sound that the operator is making when it's connecting an assembly, the connector to the engine. So we, what we do is to, we listen the sound with an ultrasonic microphone. We send this data to the PC that is running a neural network that is going to say to us if the connector was well connected or not, depending on analyzing this data that we are sending to the PC. So we first train the model, and then we have this model working with 99% of efficiency in the line. And with this, we control the quality of our process. This is another example where we use the artificial vision systems and the machine learning inside these algorithms to control the defects of our manufacturing machining parts. So we are able to control even microns of the characteristics of these parts. So we have more than 100 cameras in the same station, and we generate more than 1 terabyte of data each day in only one station. This is a huge amount of data that we have to storage, and we have to save for even 2 years. So with this, we have traceability of our process with all the parts of our process, and we are able to control even invisible characteristic for our eyes. And just the last example is the predictive maintenance that we have on our machining lines based on SPC and multivariate algorithms. So we have more than 600 sensors that are in our machines, and we send the data that we are capturing by the sensors to a distributed database that we have on our line. And we have this real-time data that we can visualize, but then we apply also different algorithms in order to get, for example, to optimize the tooling life or even to reduce the machine stops. So the operators can see the screens on the machines, and this is all the information that we are giving to them in order to take better decisions in production. So this is everything from my part. I think these are good examples of how to apply innovation in a control way in a very complex manufacturing production environment.
Thanks, Paula. That's absolutely fascinating. So I'm definitely going to be asking you some questions later on about that. Some really good examples there, and thanks very much for that. So I will we'll see you in the Q&A session in a few minutes, if that's okay. Our next presenter, and another fascinating presentation, I'm sure, from speaking to Kevin previously, is Kevin Konkos from Symbio Robotics, who have been developing software or modular software systems to enable more efficient use of robot systems. I might be wrong on that, Kevin, so I'm going to allow you to elaborate a bit more and give us a bit more detail on that, if you would, and I'll so you can give us a good flavour of what you do and some of the studies that you've been working on.
Yeah, thanks, Nick. So, you know, at Symbio, we like to say we bring AI to industrial robots because intelligent automation empowers the best of both people and machines. But more on a tactical level, what we were really doing is advancing industrial automation in applications like assembly, fastening, and parts kitting. And we're really enabling robots with sensors and artificial intelligence so they can dynamically respond to process variation and ultimately optimize task execution. And the really cool thing is we're really working with some really forward-thinking OEMs right now to execute some interesting applications into production.
Great, Kevin. Well, thanks for the intro there. You know, we wanted to ask you a couple of questions. You know, we've been discussing the automation of tasks. We've heard from some of our presenters about how this, or we mentioned earlier, how automation remains relatively low in some of these assembly tasks. And you know, you've talked about with us and the challenge of thinking about software from the beginning, and that's really kind of an important part of this. So can you tell us a little bit about how that would work and how that could help optimize the processes?
Yeah, thanks, Chris. So yeah, let's dig into it a little bit. So you know, generally the greatest challenge with automating any task today is handling the process variation, whether that's due to part location or infrastructure shifting around or just changes in robot calibration. Historically, the way developers of automation have handled this variation is they invest heavily in custom mechanical jigs and fixturing. So they really lock everything into place mechanically. And we're coming at it from basically the other end of the spectrum, and we're integrating off-the-shelf industrial sensors, endowing the robots with the intelligence so they can dynamically respond to the variation that just naturally happens in the environment. And to be clear, that really wasn't possible 10 or even 5 years ago. But thanks to more powerful compute that's provided in industrial hardened packages, and also more powerful software that's also been largely driven by the push into autonomous driving, it's very much now a reality and a possibility. And so what we do is we complement the industrial robot arm with this hardware and the software from Symbio, and we really work through the real-time API of the robot arm so that the robot can, in real time with low latency, kind of respond to its variation and then understand success and failure. So it's really learning the task, and that's super exciting for me, because now we're starting to work with robots more like we work with humans, giving them the kind of the high-level overview and allowing the robot in this case to learn how to optimize the task for itself.
In terms of the kind of hardware necessary to do that, is that like a significant investment in terms of retrofitting, legacy equipment and giving the connections, or is it something you can do it like relatively effectively and efficient and cheaply?
Yeah, no, the hardware really isn't that expensive now. You can find industrial cameras, industrial servers for relatively cheap compared to even the cost of a robot arm, which continues to come down. So no, it isn't a significant expense to go in this way. There is a certain amount of trust that needs to be considered from the OEM. They've always historically done it where they've mechanically locked the parts into place, and that's a feeling of control, even though sometimes it really doesn't work. And so there's got to be a mindset shift with the customer to think, okay, I'm going to allow my robots to do what is the right thing to do to optimize the task execution.
Absolutely. And do you have any kind of case study examples that you might highlight? I'd be interested to hear, about where some of this is working specific in the automotive industry.
Yeah, absolutely. So an interesting task we just completed with a large OEM. We worked to retrofit their torque converter integration into their automatic transmissions. So the exciting thing is we've just completed that in production. We found a 15% improvement in efficiency. We've shown that their ramp to production for new models has been taken from what used to be a week, or if not multiple weeks, to just a couple hours. And 15% might not sound like a lot, but the reality is when you're doing 3 of these a minute, 15% over the course of weeks or months really adds up to volume pretty quickly. So it's pretty exciting there. What we did was we basically retrofitted the existing robot with a force torque sensor, enabled some fundamental understanding of what the task entails and what strategies it could use, and then allowed the robot to learn the space and optimize the task for itself and find that efficiency for itself.
It's really fascinating. I know in our the digital edition we have coming out, there's a bit more detail on that as well, and I even think some videos, which is quite cool to see. I mean, there's a lot of questions I want to pick up in the Q&A as we bring everyone together, but maybe just another point. What do you think? What are some of the barriers to with this machine learning and getting these robots to do these sorts of processes they didn't before? What do you see as some of the big barriers right now? You mentioned the mindset from the manufacturers. Are there others, technological, etc., that will help move this to the next level?
Yeah, I think a major barrier today is a lack of standards. All the different robots operate with their own kind of real-time APIs. Some of them are more mature than others. Some of them work a little bit better than others. But if the industry came together and could establish singular standards, it would really allow an easier path to scale and adoption.
Fantastic. Well, you know, there's a couple other questions that we want to pick up, and I think they'll be relevant to our whole panel, Kevin. So I think that was a great kind of intro to Symbio and gives us another perspective on some of the innovations that we're seeing specifically with robotics and how it could combine. Well, we're going to talk more when we bring everyone back, but before we do, I want to spend a little time with our next guests. But thank you, Kevin, for that insight, and we'll see you we'll see you back in about 10 minutes.
Thank you, Chris.
Yeah. Great. So our next guest, the last guest for today, before we go to the panel, is Michel Morvan, who is the co-founder and executive chairman for Cosmotech. And Cosmotech, really interesting side, another perspective here, doing a lot with digital twins, simulation software, and how that is working throughout the supply chain and indeed in production processes. So first of all, Michel, thank you so much for joining us today.
Yeah, it's a pleasure to be with you. Thanks for the invitation.
Great to have you here. So I thought, why don't you tell us a little bit about how Cosmotech is using digital twins and how this software and your technology can help to optimize some of the production and supply chain processes that we've been talking about.
Yes, what we do at Cosmotech, we create this simulation digital twin, and we are a software vendor. And the simulation digital twin is a very new and advanced technology that is based on AI, but a very advanced AI that we call hybrid AI. But just one step back, what is the main problem that we all encounter in the automotive, industry, manufacturing? And I'm sure if you guys are in this business, I'm sure that you're facing the following contradictory injunction from the top management, maybe the CEO, whoever you have above. And on the one hand, they want you to be more efficient. They want the system, the factory, the shop floor to be more efficient, more resilient, and be better. And of course, all that by cutting costs. And I'm really sure that you're facing that, because everybody's facing that today. And if it's not the case, tell me, I will offer you a beer. But I don't take too much risk here. And if the problem is that, as it has been said by the previous speakers, the world we're living in is more and more complex, and on the one hand, and more uncertain on the other. And so what you need is visibility. You need visibility. So is AI going to be the magic solution for that? The answer is yes and no. Why yes and no? Well, AI traditionally, and that's what has been presented before, it's when you hear AI, you think a lot of data, and you think neural networks. And neural networks and these approaches of machine learning, they're very, very good to recognize images, recognize situation, for example, for predictive maintenance, and it's really great. But you work with data from the past, data from the present. But what do you need if you want to manage your system to be at the same time cutting costs and being more efficient? You need visibility, meaning what you need is not the data from the past or the present, but what you need is the data from the future. And data from the future, you can use a lot of things, but what you need to be able to use the second part of AI, that is the part of what we call hybrid AI, and we are not the only one calling that hybrid AI. It's knowledge about the shop floor, knowledge of all the processes running in the shop floor, and putting that in systems. And once this is in systems, and once you are able to feed it with data and things that you learn from data from the past or from the present, then you have the ability to simulate. And this is this simulation, one simulation. What is going to happen if I don't do anything? What is going to happen if this action is made or this sequence of action is made? And more than that, once you have this simulation ability, you have the possibility to be able to run hundreds of thousands of simulations to find the best way to. And then this knowledge, this information that will come from AI based on data and AI based on knowledge that you put to create a simulation digital twin. It's a twin of your factory, a twin of your shop floor, or a twin of your global industrial system. Once you have that, you're really able to have visibility and to make decisions. This decision can be automated or they can be made by human. But in any case, if you want to respond to this contradictory injunction, you need to be able to have visibility, and that's exactly what the simulation digital twin are bringing to our customer. In a nutshell, if you want to know what may happen, what's going to happen if you act, you cannot just imagine that you can know that by looking at the past, because unfortunately we have all learned at every level that tomorrow is not going to be like yesterday.
Absolutely, and I don't think I'm going to earn the beer that you offered either, and I doubt many of our audiences are. But hopefully, we can come up with some software to simulate that. Michel, what do you think in terms of getting that data? You mentioned obviously not just the past, but present and future. Does it depend on a really highly connected set of equipment in the plant and in the supply chain to kind of feed that data in? And is that, in your mind, something of a challenge? We talked with Kevin earlier about retrofitting some equipment and that you could do that actually pretty effectively. What about for the digital twin and the hybrid solution you're talking about?
Well, not necessarily. Of course, if you have great data and very fine-grained data, it's fantastic because you can do more. But let's look at a very concrete situation. Assume you have a shop floor in which you have a set of machines, robots, and running. You know that some of them, you know the sequence of, let's say cars that are going to arrive in the shop floor. And what you want is, of course, optimize the number of cars you're going to produce during the day, the OEE, right? So unfortunately, some robots are going to have failures during the day. And then you have to take into account all what is happening in the shop floor to be able to help. When am I going to have problems? When am I going to have bottlenecks? What is going to happen? And for that, either you have a kind of a coarse-grained description of when the robots are going to fail. You don't exactly know, but you have some information. And you can run a lot of simulations to find in which order to do the maintenance operation. And you can do that without a lot of data. But now, if you have, as it has been presented by our colleague from Ford, if you have great information about each robot and prediction of when the robot is going to fail, then you can optimize the maintenance operations in the robot. So the more data you have, of course, the more results you can obtain and value you can create. But even with not much data, because you gain visibility, you can gain a lot of value.
Great. I think that's a great note to kind of bring our panel back together and connect some of these issues a bit more, because I think it's interesting how all this technology comes together. So with that, can I let's welcome back Matthias Schindler, Kevin Konkos from Symbio, Paula from Ford, together with Michel, and Nick will join as well, and we can kick off this into a bit of a wider discussion. And I also want to encourage our audience to keep coming your questions. There's already some questions through, and we're gonna pick them. We're gonna pick up at them. I thought, why don't I just wanted to pick up on a point you said there, Michel, and then let the panel comment on it as well. I mean, you mentioned they're getting all the data. What about sort of what do you think the most important thing is to actually take actionable results from this data? Because obviously you can be overflowing with it as well. And what are the really keys to kind of isolate and use the data correctly to make the right steps forward, as opposed to getting a bit lost in all of that data? That's for Michel to start.
Yeah, okay, yeah, sorry. Yes, it's a very important point. The most important, and that's what we call return on data. How can you increase the return on data? You're going to spend a lot of money for having data and finding data, and the question is, how can you get return? The best answer for that is to start by knowing the problem and the question you want to answer and the decision you want to make. Because once you have this information, then by using the kind of tools I described, you can see which data you're going to need and which granularity. Sometimes you need data every second, sometimes you need data every hour, sometimes every millisecond. And this, linking the data to the problem you want to solve, rather than just gathering data, is something extremely important if you want to get value from data. And I mean, simulation digital twin is a great tool for doing that.
Fantastic. Maybe you know, perhaps to Matthias and to Paula to kind of comment on the when we talk about neural networks that you're building and the way you're using them, and Michelle referenced the need for large amounts of data often associated with AI. Is that a challenge for BMW or Ford in terms of building large enough data sets to achieve the sort of tasks that you're putting through in the plants? Maybe we can start with you on that, Paula.
Okay. Yeah, it is. Absolutely. I think that we are right now on the way to get this, and with the experience that we had here, because the slide that I show about the predictive maintenance, we have been working for more than 5 years on that project, and when you start thinking on getting data, storage data, and then run all these algorithms on those data, you try to think big. But when you fail and fail and fail, then you realize that it's not the best way to do it, and you have to focus, as Michelle said, on the problem that you want to show and to give value to production. Overall, if you are really close to production, you need the support of the people on the line to make this succeed. So they have to be part of the problem and part of the solution. So they should be on the beginning of the design of the project. This is why, since there's failures, then we work with proof of concept, and then when we get the point that we want to be, then we scale the solution. But one of the, regarding to your question, one of the problems that we have is how to maintain in a production environment distributed database on more than 20 machines in each line, that they were exposed to power shutdowns, to failures of the machines. So it's quite difficult to dimension the infrastructure that you need depending on the data and problems that you want to solve. So it's very, very important to have good design of the data and variables that you need in order to simplify as much as possible the quantity of data that we are going to use, the frequency of the capture of this data that you really need, because at the beginning we were just collecting data in continuous. So it was almost impossible to manage those millions of data up to the point that we realized that was not needed. We just have to relate with the cycle time of the machine, with the part, and then have the different data with the frequency capture that we needed, and then to dimension the problem, well dimension the problem. But this is, let's say, the problem on the plant, and this is something that the company has worked with, and right now we have a big lake where to locate all this data, and we are improving a lot this real-time data that we need to have available for the people on the plant.
Great, and maybe Matthias, if just from BMW's side.
Yeah, typically we discuss it as hard if we have unbalanced data. So yeah, when you have a look at a regular production, which is mature, running on a serious production, there are very few incidents which are happening. Typically they are very heterogeneous, so you have to have a very long time of data aggregation. So this is what made or some of the predictive maintenance initiatives pretty challenging, and this was also one of the reasons why we try to focus with AI, where we typically need large amount of data on the quality aspects. On the one hand, it's rather easy to simulate errors. So for example, if you have the part which is right or wrong, you can produce a wrong part by occasionally and take several pictures of it. On the other hand, we typically focus on transfer learning, so we do not try to focus on the neural network itself or try to set it up from scratch, but rather use well-established frameworks and just modify the last percents of it instead of starting from scratch. But yes, as you mentioned, especially when you have unbalanced data sets, it's pretty a challenge to acquire a data set which would be sufficient.
If I could just ask Kevin a question regarding managing data. With kind of like a modular system, I know from reading around regarding sort of control systems for robotics, and something that Symbio have been working on. You have a data set for that, and one of the big issues is the amount of code sometimes that's required to produce these things. Are you working with your existing data sets and possibly customer data sets as well? Are you able to combine those, or?
Yeah, that's a good question. So I think what we found with most of our customers is they sort of lack the fidelity of real-time data we would need to really use their data. So it's really more about having our robots train on their own data. And since we're so focused in one case on very low latency and enabling robots to execute the task in real time, we really focused on enabling the robot to do more like a continuous improvement, where it's learning from every cycle it's executing and optimizing its parameter set through that. So yes, the more data you have, the better the solution is. But you know, depending on how flat the data plane is, you can really get there pretty quickly with our solutions.
That's great. Oh, sorry, Nick, did you want to follow up on that?
I was just going to elaborate. I mean, going back to the initial presentation by Matthias, which highlighted, I think one of our questions came in was how many variations were there actually for a 3 series, because that was quite jaw-dropping, that figure. But I mean, this goes around the variation issue, which we saw across the board when we were writing our feature on this. It is a big issue when it comes to moving this on. We're talking about the data set, the data management there, and the variations. And Paula, when we were looking at the connection, using the audio to ensure that the connection had been made correctly, which is a fascinating thing. But variations in terms of, you have variations there in terms of different types of connector, different powertrains that are coming through, and also different suppliers for those, which might actually create a different acoustic signature depending on who supplied the connector, or how many pins, what material it's made of, etc. So the question really is to everybody, to some extent, is at the moment is variation, product variation, the biggest roadblock, the biggest challenge that you face when it comes to trying to bring automation systems, even AI, into your production operations, or dealing with, in terms of Michelle and Kevin, with your customers? I'll put that out to everyone, but I don't mind. I'll ask Matthias first. How do you view that?
I mean, of course, variation is a very important factor for us. As I mentioned, you can combine the BMW 3 Series sedan in 1 billion possible combinations. Our colleagues have calculated they can build cars for 107 years until they have to produce the very same configuration the first time once again. So this means individualization and variants play a very important role for us. But I wouldn't say this is a hurdle for automation. But for example, when using AI in these computer vision tasks, as shown, we see a large benefit of new technology, because on the one hand, conventional computer vision would not be cost efficient for many of these cases, as they try to compare pixel by pixel, and they cannot handle it, or they cannot handle it when it comes to efficiency. And on the other hand, our colleagues, they do not want to wait for a car to pass by and then remember what is the given type plate. So of course, this is a way how we can bring more attractiveness to production, because of course we want to have production employees in the future as well, and we will have to look for them to acquire them.
And I know Ford have a huge amount of variation across their models. From visiting, I think it was Saint Louis I visited, and they showed me the logistics holding for the different number of parts, which is always a headache. I mean, is that something again that's an issue for you when you were looking at the systems and the types of AI you were trying to introduce into your production operations. Clearly, variability is a big problem there.
Yeah, I would say that instead of a problem, it's a challenge because there is no option. You know, variety comes with customization and comes with flexibility. So if we want to be competitive and if we want to lead the market, then we want to adapt to this. So yeah, it is a challenge when you automate, but it's also the key point to move us further into the design of these systems. So for example, as you say with the connectors, what we did is to study the limitations of the system. So we know with which connectors we can work and with not with the ones that we cannot work. It's just related to the quantity of energy that the connector is able to perform. And the thing in this case, we work really close to the production design team. So the PD team is the one that knows our requirements and is the one that works with the suppliers of the connectors in order to get, let's say, a complete cycle of controlling our quality. They know our requirements, we know how to control it. I think this is the best way to work. We make our control systems as best as possible, and they help us to have our quality production control. But yeah, that's everyday challenge.
Nick, if I could jump in, I think I'd like to second what Paula said. I think it is a major challenge that the market's going to have to face over the next decade, if not couple decades, and you're seeing that right now, right? So the fragmentation in the market for even just different powertrains, way more powertrains today than were demanded by the market just 10 years ago, and that reverberates through the number of models, and then the product life cycles are coming down, they're shortening. And that's just a huge challenge for manufacturing because, what used to be a 5 to 7 year product life cycle is now 2 years or less. So it's a lot shorter time for manufacturers to make a break even on that automation investment.
Yeah, I would like to jump on this. I mean, on your question, Nick, and what said Paula. I really like the fact that you say, well, it's a challenge, and the first, it's the reality, but second, what I would like to say is it can be a great chance too, because in some cases, look, if you have a big diversity, you're going to produce many different models in one day. Assume that you know the sequence of these models and you have visibility on what is likely to happen during the day. Maybe you know that you can, at a moment for the day or for the week, you can optimize the sequence to use the fact that there is this diversity, to use it optimally with what you know that is going to happen. And then you can go and find a lot of value by using complexity. And that's, for me, is extremely important. Very often when there is complexity, and variability is one element from the complexity, you always think, oh, it's a problem. I love the fact you say, Paula, it's a challenge, but it can be a great chance, because when there is complexity, if you have visibility, you have a lot of value to go and be able to find. And I think that's for the competitiveness of all actors in the industry, being able to create value from this complexity is the greatest challenge.
Good stuff.
Thanks,
so
sorry, Chris. Okay, Chris, sorry.
Oh no, sorry, Nick. I wanted to just pull a question from. I mean, I agree that this process variation is really the key point here, and I think we would and should spend more time on it. I did want to pull a question that we had from the audience, actually, which was whether anybody has had experience or case study for process industry digital twins working with cobots. For example, how multiple layer perspective models might help advancements of cobots. And I might, Michelle, that's a good question for you to start with, and then, but maybe Paula as well, because I know what in the emerging technology areas you're working on, I do think cobots are one of the focus areas as well. So I'd be interested in that perspective too.
Well, we didn't specifically work on this one, but it was one of the elements we had to take into account in the context of one of the factories and the software we deployed. So we see it and the way to optimize their use in a more complex environment. One of the key questions. But what I would like to share to respond to this question is, the very important thing is not to consider one part of the system alone. If you say, okay, let's use cobots to optimize this or that, if you don't work globally, well, you're not going to gain all the value you can get. So for me, it's one part of the system, but not the only one, and we have to consider it as the whole. I don't know what the others think about it.
Yeah, completely agree from my part. We, as you say, Chris, we have worked a lot on the deployment of the collaborative robot. We found technology, a lot of advantages in this technology to our automation production system, but related to digital twins, as Michelle say, we are focused on the complete production line, because I think the first value that you can take from this system is first of all visualize what is invisible for the daily operators or daily management, let's say, and then when you have all this data in the screen, then you can apply some intelligence. But the info that this visualization gives to the employees is quite valuable. In regarding to the cobots, I can say that we are right now in two projects. One is a full-year European project that we are working on digital twins. We are starting from in one hand from the layout and asset digital twin from the line, and then on the other side we're working on the production and optimization of the mix schedule, tuning life of the machining lines, and the cobots are only one part of this production line. And then the other project that we are working on, this studio project, is focused on cobots, because what is true is that if you go deeper on the let's say function of this, or functionality of this robots, is quite different, or the problems that these robots can have are different than the industrial common robotics. So we are working on a project to have this predictive maintenance on this specific kind of robot, because the problems that we have found and the way that they work is quite different.
There is a sort of follow-up question to that, Paula, just quickly. When it comes to the predictive maintenance, are you using different robots, different algorithms? Do you have one algorithm that works across all your robots, or do you have different ones for different areas?
Yeah, you need to use different, even for the same machine, you need to use different algorithms, because each algorithm is designed for each kind of problem. And then you need to have this problem in order to analyze the problem and compare with the, let's say, correct functionality of the system. So we use for the same machine the different algorithms. The ones that we have got better results are the SPC ones, the multivariant SPCs, are the, let's say, first complex but yet simple algorithms that you can apply and see the results easier.
And maybe Matthias, in terms of, I mean, I know BMW has been doing a lot with AGVs and other kinds of mobile robots. In fact, even spun off a division recently, I think, to focus on that. In terms of how you're working with, is this a focus area for how you're combining some of the AI algorithms and solutions also for mobile robots, cobots, and AGVs, for example?
Yeah, absolutely right. Some weeks ago, we launched a new sub-company, which is called IDEALWorks. They are offering for the entire market AGVs, so autonomous guided vehicles for logistics tasks. It was an initial idea by BMW, and right now they have funded this new company. In general, they're using the very exact algorithms we are using for object detection. Of course, also the robot has to detect some certain things. On the one hand, of course, boxes. He might not collide with anything, so he has to identify which are pillars, where are some other, maybe forklifts or people or even bicycles crossing. And they are using the very exact algorithms we're using. Of course, they try to solve a little bit different problem, but in general, they use the same frameworks. They also use the BMW labeling tool. Of course, they focus on simulation because nobody really wants to get hurt by a robot. So this is typically something you try to simulate in advance and try to teach the robot not to do in real life. So this is why they have a more or less great simulation environment. They try to rebuild significant parts of plants or logistical areas, and afterwards they train their logistical AGV, and they only test it live, but they can do a lot of training before with synthesized data, and which accelerates the entire training process and which helps them to make their robot safe in the end.
There's a question, actually, it's coming directed at Kevin, but I think actually it's one that again applies to all the panelists. It's a fair question in a way. Vision systems have been around for a long time, used in different capacities, but the question is the improvement in the vision systems we're seeing now, is it an important element in allowing robots to accommodate the variation that we talked about earlier on? I mean, how do you sort of view that? I'll go to you first, Kevin, on that one.
Oh, absolutely. I think the improvements in the vision system, not only the improvements of the performance, but the fact that they're now being packaged for to meet the requirements of the factory floor and operating over, a very wide range of temperatures in a dusty, dirty environment is a key enabler to giving these robots the sense of sight necessary to respond to the variants that they need to execute their task. So yeah, that's absolutely true. And I'd say, especially when you're looking at the active sensors like 3D vision, a lot of that's driven by a multitude of markets that are interested in this technology. So it's not just automotive manufacturing.
And sorry, Matthias, I know the core part of the presentation you gave us at the beginning was vision systems regarding that. I mean, and I'm assuming for Paula as well, that you showed the engine blocks being checked and scanned and the terabytes of information that you're storing on the back of that. So you both agree that the advance in vision systems or their utilization has improved a lot and helped with the variation challenge?
Yeah, I completely agree. We can say that the artificial vision system are, let's say, our flag of quality right now. Not only in real time, but also because you can store the images and then post-process if you got a problem outside of the factory. And in terms of robots, these vision systems are, let's say, the eyes of the robots. So when you work with cobots, you have the sensitivity as the hands of the operator, and then you have the cameras as the eyes of the robot. So we are getting closer to have the best of the human and the best of the robots on the same time. So if you can help the robot to recognize with which part is working, with engine, with door is working, of course it's going to perform better the task. So yeah, absolutely is the best way to control and to work with this vanity.
Yeah, I think pretty much the same. Of course, when we do conventional or simple inspection tasks, the new algorithms can help us to use cheaper or fewer cameras. So as seen in the type plate case, we now can use one camera to take a picture of the entire car, which wasn't the case in the past. In the past, typical computer vision was working on a 10-inch by 10-inch or even closer or smaller area to have this very high resolution, which is not necessary any longer, which makes computer vision cheaper and brings a broader area of application. On the other hand, more or less mounting sensors or eyes onto robots means a change in paradigm, because in the past they typically were very heavy stuff beyond any fence or cage, and typically they were moving without seeing anything. So of course the decrease in cost allows us here to have more flexibility to have smarter robots, and which are probably even more precise.
Great. So we're at a little bit less than 10 minutes left, and there are loads of questions flowing through. We won't get to all of them, but what I will say to our audience firstly is questions that we don't get to, we'll make sure we put to our panel and we get some answers, and we have some follow-up on that. But I thought one interesting point, and I think Kevin referenced it, just in terms of, I'm interested in comparing how some of these developments are happening outside of automotive in what you're seeing. So, Kevin, maybe starting with you there. Are you working with in other industries? Are you seeing a fast development, slower development, other things that automotive maybe could learn from other industries? And then Michelle, I'm interested to hear that perspective from you as well.
I think what I'm seeing is it's very application specific. So if we're talking about,
I can go. Oh,
go ahead.
Go ahead, Kevin.
No.
Why don't you start, Kevin, and then we'll go to Michelle.
Okay, very good. So what I think I'm seeing is it's very application specific. So if you're talking about an application like picking, I think other verticals like retail logistics, e-commerce is very much leading the way there and really trying to drive home a solution. And I think that has a lot to do with just the realization that they need to innovate, or some big players in the market are going to really grab market share from them. When it comes to assembly, I don't think there's any vertical quite like automotive having the really fast cycle time requirements, and yet the diversity of form factors that automotive has to see. The only thing that somewhat compares is maybe white goods or aerospace and defense. And I think automotive is certainly driving, is leading the way in that space.
Yeah, on my side, I can give just one example. It really, as Kevin just said, it depends on the subject we want to treat. Some of them are very automotive specific, some of them are more general. But one that we started to work with in the energy sector on very big electric networks was the way to be able to optimize maintenance and renewal of equipment. So this problem, we solved it, and we have a software for very big electric networks. They are used for to optimize expenses of 1 billion every year today. And it happens that when we started to work with in the automotive industry doing simulation digital twin, we realized that there were exactly the same problem to optimize the way to manage obsolescence of robots. And over a period of time, what is the best way to manage maintenance and renewal of aging robots, knowing that you have the problem of the skills of the people maintaining them, but also the spare part, or may they disappear if you wait too long, or they will be very, very expensive. And how can you make the best choice to optimize on a day-to-day basis, but also over a long period of time? And we learn, and we reused a software that we have developed, the digital twin, simulation digital twin developed in the energy sector, and we adapted it for customers in the automotive sector for managing these problems. Once again, if you want to make the best investment and maintenance decisions, you have to have visibility on all the cascading effects. So you can use this kind of software from one industry and bring it to another one, which we did.
Have we got time for one more question, Chris?
Yeah, let's do one more question. Nick, why don't you put the last question?
Well, right back to the beginning to Mateus's presentation, but it will come across to Paola as well. the case study that you showed us with the vehicle type badging, how long did it take for that program to be put together? If you can give us, I don't know if you can, but if you can give us some sort of time scale on that. And similarly, Paola, with we'll come back to you in a minute with the I think with the acoustic, you know, how long those projects actually take. A kind of a rolling on broader question. We're talking a lot about managing data now, managing it better. Are these programs getting faster to produce? Are you able to get to the end of these programs much faster than you used to be able to? Obviously, you demonstrated a little bit of the process that you use involved in that. But going back to the initial question, sort of how long's the sort of time scale we're looking at for something like that?
Yeah, so we started with the project in 2018. And of course, the type plate case was one of the first cases we brought up running. But there was a long way of development. Typically, we started with very low cost and very rudimentary first proof of technologies, when we took just simple phones we had around and tried, okay, what is in this neural network discussion for us in production. And after seeing first results, okay, we got the funding, we started to initiate a larger project. And then it took us probably around about 9 months to bring this kind of type plate use case running up to a quality where we bring it to production, because of course we have to have a very high level of prediction. On the one hand, we have to have a very robust detection of whatever car, whatever type plate, whatever combination might appear in this specific case. So, but today it would probably take us some hours to set up the AI, which is much more important and takes much longer for us, is we call it system integration, because of course you have to have a trigger, especially in Europe. We want to take one picture and no video stream of our cars. You have to have the target, so the order configuration. This is nothing the AI knows itself, so you have to have a connection. And as we have legacy systems, the interfaces can be challenging or pretty time consuming to connect. And in the end, you have to write it into any kind of quality database. This is one more IT legacy system, which is years old, and this makes it quite heavy and to connect. So the AI is one core part, which is right now available off the shelf. So probably some hours or even less to set up a very easy use case. But bringing in the entire interfaces and connect to legacy systems can take you more than years.
Maybe any last points from the panel, Paula or Kevin and Michelle, just on the timing of those kind of stuff? I think it's a really interesting question about how these, how long this is taking to, how the time is perhaps compressing.
Yeah, I will share the experience that we had with the Click Hunter, that is the system of the sound. In our case, it's quite different because it was a deployment and from the plant. As the design of one of the engineers of my team, genius, realized that one way to detect the, let's say, correct connection of the disconnectors when they are in the position that you cannot detect by artificial vision, that it was the sound. So this was a very, very long way, because we started, as I said, studying the different connectors, the energy that these connectors were emitting. But we started with simple microphones. So I would say that the big challenge was not the neural network. It was to find the way to filter the sound in the way that the ambient sound or the pneumatic sound that you have on the machine, or even the radios of the operators are not, let's say, making the system fail. So when we got the point that we realized that with the ultrasonic microphone, it was going to null all this ambient sound. This was the inflection point of the project for the efficiency of the neural network to get up to the levels that we are right now. And then this is a continuous project, because we work with this. We have systems on the line running for more than 3-4 years so far. I think this is a good news for us because it's a robust solution, but we are continuously updating with the necessity that we have. For example, we are right now working on the wireless solution. Because if you want to work in a different position of for example, of the car, you cannot have a wired ultrasonic microphone. But if you want to send the big amount of data that you generate with the ultrasonic microphone, you cannot perform with Bluetooth or simple Wi-Fi that we have right now in our houses. So we had to be working on the developing of this proof of concept that we are right now trying on the line. So again, these projects are always long and hard projects, but I think that the most important part is to get in the small parts, and then you can generate value, generate a product that you can work on the line, and also apply a lot of effort into make this product industrialized. Let's say if we have a system that works and very well and is very robust, but it's difficult to configure by an operator, or if we have a new engine with new connectors and the configuration and the training of the model is very, very hard, then it's not going to work. The people is going to shut off. So I think this is the success of this system, that we spend a lot of time making the system simple for the operator and the employees, but complex inside with the data that we are and the algorithms that we are generating.
That's great insight. I mean, we've come a bit over time, but Kevin, any kind of final words on that? And also, I mean, perhaps any examples of the time that it takes for some of these that you kind of want to share and how that's evolving.
Yeah, I mean, I'd say for us, the schedule driver isn't as much the software development, the application development, but it's more around receiving the hardware that we need to show the lab demonstration that our customers demand. My hope is that as we continue to deliver more applications, they see the value of maybe skipping some of these steps and going straight into production, so that we can enable the robot to learn on the job and really shorten that delivery cycle a lot. But that's going to have to come in time, and that's I understand they're correctly very risk averse to that, and but hopefully that does come in time.
I can imagine some colleagues of Matthias and Paul is a little bit nervous about that going straight into production, but definitely appreciate that some room for innovation and risk there. Michelle, any parting words on that? I know the digital simulations can go really fast, but you know, what do you see this?
Yes, but it's an extremely important question, in particular today, because if we want, I mean, we're a software vendor, so we have existing software that we can implement for and configure for specific problems. But what is very important today is two things. First, having adoption by final users. As Paula said, it has to be simple. And that's the first thing. It has to be adopted, and it has to provide value for the person who is going to use it. Otherwise, it's not going to be used. It can be the greatest AI, it's not going to be used. So that's the first thing. The second thing, it has to create value fast. We are targeting 3 months value creation. So you install it, depends a couple of weeks or months, and then after that, the use has to bring value in the next quarter. Otherwise, once again, in the current situation, it's not possible for automotive manufacturers to invest in these solutions. So the timing is extremely important, and going fast is extremely important.
I think that's a good point to sort of wrap up here with. We need to press timelines. We know ROIs need to be faster and more compressed than ever as well to get these investments as you laid out. But this has been a really fascinating insight, I think, from across our panelists here, across these different technologies, robotics, automation, AI possibilities, AI perhaps particularly the key in unlocking a lot of this here. So I want to thank each of our guests, Matthias, Kevin, Michelle, and Paula, again, for all of your time and insight, and at least in this last week ahead of the holidays. We really appreciate it. So thanks first and foremost to all of you.
You're welcome. Thanks for the invitation.
Thank you very much. Happy holidays to everyone.
Indeed, and thank you to our audience as well. You know, for so many of you for tuning in, taking some time, and I hope you've enjoyed it and got as much detail, because there was a lot of great stuff here. We'll have an on-demand version as well available, so you can go back and understand more. You know, for me and Nick, I think we really enjoy what we got out of this. Nick, we you know, I need to hit it in 30 seconds, but what's a highlight for you, considering, you know, you've just come right out of a lot of research for our issue? I think we could probably produce a couple of more just in the back of these discussions.
Yeah, well, I was going to say we certainly could. Well, good to know that we weren't far off the mark with what we've produced, so hopefully we can read that. But really, just some great insights into the projects that they're doing, and from Michelle and Kevin as well. You know, a really good insight into the sort of supplier developer side, where that's coming in, where you operate with your customers and the challenges. I use the word challenges, not problems now. I'll obviously temper my language on that. But very interesting. And again, the AI, the variants, and the way that you're tackling it are very interesting.
Great stuff. So thanks again to everyone. Again, a thanks as well for Symbio as our partner for this live stream. Encourage you to check out more. You can find out more on the AMS website as well about the projects and areas that are happening there. And of course, I'm sure Kevin will be glad to take more questions, and we'll connect those of you who had other questions specifically to Kevin and to other panelists. We'll make sure those questions are passed to them if we didn't get to answer today. For those of you looking a little bit ahead to the new year and all the fun ahead, for any of you particularly interested in Brexit, you know, when we return in the new year, we've got a live stream focusing on well, what it means, who knows what it means, right? But hopefully we know by then. But more importantly, what we do beyond Brexit in terms of navigating global trade and customs. You want to join us for that one? We'll have experts from Volvo and Jeffco, and we have a link which will come through in the chat in a moment, and you can register directly for that live stream. If not, find it on the Automotive Logistics website and join us on January 13th as we look at Brexit and global trade opportunities. You can find all of our digital content, the digital edition that we mentioned, which is publishing tomorrow on automation. It'll be available on the Spotlight page and other sections of the Automotive Manufacturing Solutions website. Likewise, in Automotive Logistics, we've got a host more other content, live streams, digital events, and we're building towards our Automotive Logistics and Supply Chain North America Live conference, February 2nd, 3rd, online. Register now. It's on our website. More details, again, you can find it on Spotlight and the Automotive Logistics site. We'll also be looking at areas of automation there too, not least on AGVs, picking, and some of the topics that we dig through there. So hope many of you will consider joining us then as well. Besides that, it leaves me to thank not just our audience and participants, but our team, Nick for our work and help on this, our team behind the scenes helping to put together content and keep our live streams and other content moving ahead. So glad you could all join us for that. It's been a great year from our side. I do want to wish everyone a happy, healthy, safe holiday in these times. Looking forward to 21, some light in the tunnel when it comes to other things, but lots of other progress that we can see, and from the great talent that we've heard about today on the panel. So lots to look forward to. We'll be covering it here at AMS and Automotive Logistics. So thanks again to everyone and to our panel. Have a great holiday.
Thank you.
Thank you.
Thank you. Good holiday.
Thank you, everyone.